Let A, B, C be positive numbers. There are finitely many positive whole numbers, x and y, which satisfy the inequality. A to the x is greater than c times b to the y if, and we have options for a and b here. Interesting, okay. So my first instinct here is to write everything on one side of the inequality. Actually, maybe this won't be such a straightforward thing because okay, so maybe that's not quite the best thing to do. Maybe instead taking a logarithm of both sides would help. A, B, and C are positive. Like I would like to write everything either in terms of a common base, A and B, or in terms of a common power, X and Y. Okay, so my my new sort of intuition here is if B, like let's say I have for fixed A, B, and C, let's say I have a pair X and Y which satisfies this. Well, if B is less than 1, then I can just let Y get bigger and bigger and bigger. And this right-hand side will get smaller and smaller and smaller. And so that gives an infinite number of solutions. So does that say that for sure I need B to be greater than 1? Now this won't work in the other direction because, like it doesn't work in the sense that I can just let X, if B is less than 1. Yeah, so let's look at it this way. So if B is if B is less than 1, I can just let Y be arbitrarily large, and this will work. So I need B to be greater than 1. In fact, if B is less than or equal to 1, then making Y arbitrarily large will work. And there's an infinite number of values of Y that'll work. If B is greater than 1, it's tempting to let X just get larger and larger and larger, because then this whole thing will get smaller and smaller. But if X is getting larger and larger, this may also, or if this is getting smaller and smaller as X gets larger, this may also be getting smaller and smaller, and it may be doing that faster than the right-hand side. And in fact, we're going to need this. So we need B greater than 1, and we probably need X, or A. Well, what if I write this? Okay, so B. There's only one solution, one option given with B greater than 1. But I want to look at I want to rule out the other possibilities. Oh, wait a minute. Yeah, some of the options are ors and some of the options are ands. But anyway, I want to rule out, I want to show that A has to be less than 1. So let's start with the original inequality again. And now I have A to the x minus y is greater than c times b over a to the y. Now, if a is greater than 1, then we can do the same thing. If a is greater than 1, we just let x be arbitrarily large, and this left-hand side just keeps getting larger and larger, which would give an infinite number of solutions, and so we can't have that. So we need a less than 1. And this is option, so we need b greater than 1, a less than 1. This is option D. Yeah, this is kind of a cool problem. Yeah, not exactly the kind of problem I would typically see, but yeah, my first instinct was to just rearrange this and kind of have the dependence on x and y be kind of put together. That didn't really work though, because the bases here, a and b, are different. And so I figured, let's just manipulate the equation to get things kind of together in some form like this. And then, the fact that everything's positive, understanding how exponents work when the base is greater than 1 or less than 1 was kind of key here. The fact that the right-hand side depends on y, but the left-hand side does not, means I can kind of play with that as a function of y. And then I just tried to do the exact same thing, except here, the left-hand side is a function of x, but the right-hand side is not, so I can kind of control things on the left-hand side as I change x. Yeah, I'm not sure I have too much more to say about this one, but if I do, I'll put it down in the description. Thanks for watching.